of an industry such as mining or quarrying is the crushing operation. This is the ultimate test of machinery and materials, the ingenuity of man, and the durability of design and metal against the forces of friction, constant motion, dust, and rock. In the early days, miners used pots and dollies or primitive stamp mills to crush their ore so that it could be processed and the precious minerals extracted. Hammer mills, the first great breakthrough in rock crushing technology, date back to the beginnings of mechanized rock breaking. They're still in use today, in areas where there's little or no technological support, or where extremely friable materials such as limestone, coal, or even sugarcane are being processed. The advent of the cone gyratory crusher was the next major step. And that type of crusher dominates today. There is hardly a mine or quarry in the world that doesn't rely on it. The next significant advance is in the Wescone crusher, a machine that follows the broad principle of the cone gyratory crusher, but works on an entirely new operating principle. The Wescone crusher embodies a new concept that is expected to revolutionize the operations of mineral resources companies worldwide. It is smaller and lighter than a conventional crusher of the same capacity, yet its performance is better, more cost-efficient. It has far fewer moving parts than a conventional machine, and it does its work with a lot less vibration, noise, wear, and power consumption. And the end product is measurably better than its conventional counterparts. The external differences between the Wescone and a conventional crusher of similar capacity are obvious. But it's inside that the differences are most important. We'll look more closely at what makes it tick in a few moments. Why and how did the Wescone crusher come about? The concept was devised by 4 West Australian engineers, each with extensive experience in engineering and repairs of crushing equipment. They had studied the enormous repair and maintenance problems associated with existing gyratory crushers and pooled their knowledge of the subject to find a better way. They set out to develop a device that eliminated or dramatically reduced the problems, while at the same time improving efficiency in terms of acceptable crushed product weight per hour. Some months of concerted effort produced a new, unique, and simple principle for generating a crushing motion. The motion is the same as that generated by a spinning coin. As the coin starts to slow and its rotation changes from vertical to horizontal, so the vertical movement increases relative to the horizontal movement. This nutation, as the motion is called, is the basis of the action incorporated in the crushing chamber of the Wescone crusher. The principle is a significant departure from existing technology. The inventor enlisted the aid of Curtin University of Technology. Extensive scientific testing of the principle was undertaken both at the university and the research center at Ledger Engineering. This work was assisted by a grant from the Australian government through the Department of Industry, Technology and Commerce. The Wescone crusher has significant advantages over conventional crushers in most aspects of operation. The crushing component is driven directly by a vertical shaft and an offset drive component. The simplicity of the drive system minimizes lubrication and sealing problems. And simplicity is the key to the Wescone design. There are only 10 principal components, compared with 30 in a conventional crusher. The number of moving parts has been reduced from 14 to just 3. This dramatically reduces the level of friction and mechanical inefficiencies and cuts potential maintenance requirements to less than 50% of that in existing designs. And there are more advantages. Traditional crushers generate a high eccentric mass. This limits the size of crushers and the speed at which they can be operated. Rigid, massive foundations are needed to match the high dynamic loads generated. But the gyrational drive mechanism in the Wescone crusher creates an extremely low eccentric mass, which results in minimal horizontal dynamic loading. This means the maximum size potential of crushers can be substantially increased, at the same time reducing the requirements for foundations, thus saving costs. This offers three main advantages. Because the Wescone crusher has reduced foundation requirements, it can be considered to be transportable. The increased operating speed allows a greater throughput of product. And greater size potential of the machine provides for a marked increase in tonnage in major mining operations. Let's go back now to the operating principle. The major innovation is the form of gyration. The Wescone crushing head gyrates, or oscillates, about the center point of its own vertical and horizontal axes. In traditional crushers, the gyration is about the intersection of the drive shaft and vertical axis of crusher. So, in a traditional crusher, the whole crushing component tends to move from one side of the crushing cavity to the other. This results in a gap on one side of the crushing zone, while achieving a specified minimum product size on the other side. It's the gap that allows up to 40% of the throughput to pass through the crusher with incomplete or no crushing. In the Wescone crusher, the head moves from side to side at the uppermost points, in much the same way as a traditional crusher. This induces a pre-crushing action on the ore. At the lower points, the side of the crushing head nearest the open point moves upwards, thus closing the gap for final crushing, while the opposing side moves downwards to release the fully crushed rock. This action greatly reduces the size of the gap and retains full crushing capacity. That means the proportion of acceptable product is increased from about 60% of throughput to more than 90%. This increases the efficiency of the crusher by about 50%. Field testing on diorite, one of the hardest rocks, resulted in throughput being doubled compared with similar size crushers, with no oversized product, compared with traditional averages of 35 to 40%. 10% less power per ton throughput was consumed by the Wescone crusher, which represents a 40% reduction in power consumption per ton net product. The low level of oversized product is important because half to three-quarters of the machinery in a typical closed-circuit crushing plant is there for the sole purpose of screening out oversized material and sending it back for crushing again. Some of it will go through the system for up to 11 passes or more before it is acceptable. Eliminating this repetition can significantly reduce plant requirements, thus reducing capital expenditure, ongoing running and maintenance costs, power requirements, and replacement costs. Size is an important feature of the Wescone principle. Traditional machines are restricted to about 2 feet diameter because of their complexity. But the Wescone crusher can be built as small as required, opening up new possibilities for applications such as on-site fragmentation for ore sampling, or crushing for small or marginal mining operations. Beyond the mining and quarrying industries, applications such as in the pharmaceutical industry, the grain milling industry, the sugar industry, and others become possible. To summarize the advantages the Wescone offers: reduced initial cost, reduced energy requirements per ton throughput, reduced spares requirements, reduced transport costs, reduced return side plant requirements, reduced foundation sizes, reduced maintenance, increased crushing, increased gross throughput compared with similar size crushers, and improved control of finer product sizing. Excellence, innovation, and achievement. The qualities represented so clearly in the development of the Wescone crusher.